So hello everyone, today we are going to learn about capacitors. Capacitors are tiny components that store and release electricity. From big electrolytics to small ceramics, each one plays a key role in filtering, timing or stabilizing circuits. So in today's video, we are going to learn about three things. What is a capacitor? How are they made? And why do we use them? Now, let's talk about something that's in almost every electronic circuit, the capacitor. A capacitor is an electronic component that stores and releases electrical energy. Think of it like a mini rechargeable battery. It charges up really fast, then discharges just as quickly. Inside, it's made up of two metal plates separated by a non conductive material called dielectric. This dielectric stops the charges from jumping across but allows them to build up. When you connect a capacitor to a power source, electrons pile up on one plate. This becomes the negative side, and positive charge builds up on the other plate. This buildup creates an electric field, storing energy in the process. And when the power is turned off, the stored energy flows back into the circuit. It's super useful for things like filtering, smoothing power supply, or even in camera flashes. So in short, capacitor, it soaks it in, holds it, then gives it back, same like a sponge. So now let's do a demo. For this demo, we will need one breadboard, one 9-volt battery, one LED, one resistor, 220 ohms or 330 ohms, one switch, one capacitor, and jumper wires. So as can be seen here, this is the connection required to check. Let me zoom in. So let me explain the connections. The positive end of the battery goes to one end of the switch, the negative to the second. In the middle, common terminal goes to a resistor, and the resistor goes to one terminal of the capacitor. The other end of the capacitor connected to the shorter end of the LED, and the longer end of the LED take it to the ground or the negative terminal of the battery. And start simulation. When I turn on the switch, look what happens. The LED glows and goes dim. I'll explain to you all how this happens. I stop simulation. Now let me connect it without a capacitor and look. When I turn on the switch, the LED stays on but doesn't go off. With the capacitor, it used to go off. It used to go dim, but now it stays on as long as the switch is on. Here's what happens when a capacitor charges and discharges, shown on this graph. On the left side, you see the charging curve. When we connect a capacitor to a power supply, the voltage pushes electrons onto one plate. But it doesn't charge instantly. Instead, the charge builds up gradually over time. Following this curved line, it starts fast, then slows down as it gets closer to full capacity. Now look at the right side, discharging graph. When the power supply is removed and a load is connected, the stored energy flows out. Again, it doesn't drop off instantly. Instead, it gradually releases its charge, shown down by the downward curve. This smooth charging and discharging behavior is what makes capacitors super useful for timing circuits, signal smoothing, and even power backup in electronics. So just like a sponge, slowly soaking water and then slowly squeezing it out. That is a capacitor in action. Now let's see how a capacitor behaves in an AC circuit. In a purely capacitive AC circuit, current I doesn't follow voltage V exactly. In fact, it leads it by 90 degrees. That's right, the current reaches its peak before the voltage does. But why? Because when the voltage starts increasing, the capacitor starts charging rapidly, causing a high current. But as the capacitor gets full, The voltage keeps rising while current starts dropping. Then comes discharge. As the cycle reverses, this repeating pattern creates a sine wave that you see. The blue curve is voltage and the purple curve is current. Over on the right, that phasor diagram shows the same thing. Current is 90 degrees ahead of voltage. This phase difference is key in power factor, filters, and in how capacitors control signal timings in AC systems.